We are told that V is the midpoint of the line segment P to R. The midpoint formula on page 18 of the formula book will help us here. It says that the midpoint between x1, y1 and x2, y2 is x1 plus x2 over 2, comma, y1 plus y2 over 2. V is the midpoint of PR, and we know the coordinates of both these endpoints. P is equal to 7, 10, and R is equal to 11, 4. To use our formula, we'll label our first point x1, y1. Here, x1 is 7 and y1 is 10. We'll label our second point with x2, y2. So we've x2 equal to 11 and y2 equal to 4. From here, we just need to sub into our formula. 7 plus 11 over 2 is equal to 18 over 2, which is 9. 10 plus 4 over 2 is equal to 14 over 2, which is 7. So our answer here is that the coordinates of V are 9, 7. We are asked to show that two lines are parallel. A key point here is that lines are parallel if they have equal slopes. If we find the slope of UV and the slope of QR and show that they are equal, then we'll know that the lines are parallel. Since we want to use slopes, we should look up the slope formula on page 18 of our formula book. It says that the slope m between x1, y1 and x2, y2 is m is equal to y2 minus y1 over x2 minus x1. The first slope we need to calculate is uv. We know the coordinates of these points. U is 4, 6, and in part A we found that V is 9, 7. We label our first point, U, with x1, y1, and we label our second point, V, with x2, y2. To find our slope, we just need to sub these values into our formula. Seven minus 6 is 1, and 9 minus 4 is 5, so our slope here is 1 over 5. Now we'll have to calculate the slope of QR. Q is equal to 1, 2, and R is equal to 11, 4. We'll label our first point with x1, y1, and our second point with x2, y2. To find our slope, we'll sub these values into our formula. 4 minus 2 is 2, and 11 minus 1 is 10, so we get 2 over 10, which simplifies to 1 over 5. This is the exact same as the answer we got earlier. Since the slopes of the lines are equal, we can conclude that the lines are parallel. We are asked to find the area of the triangle PQR. A formula on page 18 of the formula book will help us here. It says that the area of the triangle enclosed by the origin 0, 0, x1, y1 and x2, y2 is a half times the absolute value of x1, y2 minus x2, y1. A crucial part of this formula is that one of the points must be the origin 0, 0. So to use this, we must shift one of our points so that it becomes the origin. We are concerned with the triangle PQR. Let's list out their coordinates. Q is 1, 2, P is 7, 10, and r is 11, 4. We'll need to shift one of these so that it becomes the origin. We could pick any of these points, but I'll choose Q since it contains the smallest numbers. So, the question to ask is, what must I do to Q to make it turn into the point 0, 0? Well, the x-coordinate is 1, and to make this 0, all we have to do is subtract 1. The y-coordinate is 2, and to make this 0, we just need to subtract 2. So our translation is to subtract 1 from the x-coordinate and subtract 2 from the y-coordinate. We must apply the same translation to P and R. P has an x-coordinate of 7, so subtracting 1 would give us 6. It has a y-coordinate of 10, and subtracting 2 would give us 8. So after we translate P, we get 6, 8. R has an x-coordinate of 11, and subtracting 1 gives us 10. It has a y-coordinate of 4, so subtracting 2 gives us 2. So after we translate R, we get 10, 2. We've now gotten ourselves into a position where we can use the area of a triangle formula. We've translated Q so that it becomes the origin 0, 0. The next point, 6, 8, gets labelled with x1, y1. And our other point, 10, 2, gets labelled with x2, y2. From here, it's a matter of subbing into our formula and performing the calculations. Six times 2 is 12, and 10 times 8 is 80. 12 minus 80 is minus 68. Now, let's deal with these vertical bars, the absolute value. These mean that we should turn the number positive if it isn't already positive. So the absolute value of minus 68 is plus 68. Finally, a half times 68 is 34. Area is always measured in square units, so that's the unit here. The translation UV with an arrow over it is the movement required to get from U to V. We know that U has coordinates 4, 6, and V has coordinates 9, 7. So how could we get from U to V? Well, the x-coordinate changes from 4 to 9. So the shift here is plus 5. The y-coordinate changes from 6 to 7, which is a shift of plus 1. So the translation here adds 5 to the x-coordinate and adds 1 to the y-coordinate. The point S is defined to be the location obtained after we perform this translation to Q. The coordinates of Q are 1, 2. To find S, we just need to perform the translation we had. Add 5 to the x-coordinate and add 1 to the y-coordinate. 1 plus 5 is 6, and 2 plus 1 is 3. Hence, the coordinates of S are 6, 3.